plan of the new school, and we really wanted to make it green and renewable energy, so that's what we focused on mainly. Yeah, sorry.
You might have to tap on the bit you got possibly over.
So renewable energy is energy that we can use, something like the school, we are also able to replace. So this would be natural resources like water, wind, or sunshine. And then the next one is non-renewable energy. So this is energy that we can't replace. So this would be like fossil fuels, and we'd like to switch over to using renewable energy because it is a lot better for our environment as it's creating global warming. And since we are going to eventually run out of it, it is good to start looking for a solution to this problem.
So basically we went to the finance and we wanted to know how much the cost of the energy the school uses, like in each season, like autumn, winter, spring, and summer. And also we wanted to know the amount of energy they used. Actually, the thing that we didn't know was electricity was because they couldn't tell us how much the usage of electricity, and we had to find that ourselves, which Alex and Lena calculated.
Yeah, we did that by, we knew how many units of energy, we knew how much we paid, how much we spent each season on electricity, and we found out the unit price, which was between 31 and 40 forints per kilowatt, and we calculated roughly how many units we must have used each season. That's what we put into our table. So the types of renewable energy that we felt would be suitable to use in the new school building were mainly solar and wind energy. And we found that there were two types of solar panels. One was a photovoltaic cell and the other one is a hot water tube cell. And we also found that there were two main types of wind turbines, a horizontal and one with the vertical axes. And there was also another type of solar panel which is called the smart flower, and actually Alexi told us about that. We didn't know about that ourselves. That's quite new, and it's really interesting because it's got loads of 11 or 12 panels in the shape of a flower, and it's able to rotate and find the sun where it is, so it's more efficient because of that. And we tried to see if that, and that's it, you can see it in the picture here as well. And we thought we could include that in our plan. And then we eventually decided to discard that idea because it was too expensive, although it's very efficient and eco-friendly as all the other renewable sources. And then there are pictures of the other two as well, the wind turbines. That's a vertical, the vertical axis. And this is a hot water tube solar panel, and the other one's with the photovoltaic cells. So just for visual people. So the wind turbines, there's two different types. The horizontal and vertical, as I mentioned.
So the vertical wind turbine, so we thought that this one would be better for our school because the horizontal, it always needs wind. They both need wind, but this one, it can work and produce electricity without always having the means of moving, right?
It doesn't have to be pointed into
pointed
wind,
just at
which
that.
is an advantage.
So we thought this would be the best option, and then as stated in this chart, we looked at the different brands of it and we're comparing the prices. But I guess we later discussed the advantages and disadvantages, but this one is more expensive than the horizontal one, so that is a disadvantage.
So this is what it looks like. There are advantages to it as well as disadvantages. I mean, some of the pros are that there's no stress on the blade because it doesn't have to turn and find the wind itself. There's no stress on the blade, so it doesn't wear off as easily, and it stays efficient for longer. It's compact and it can be easily placed on rooftops, which is good because we don't really have space to build a whole wind farm. So if we do want to make use of the wind, then we have to place the turbines on top of the building probably, because it wouldn't be really safe to have them on the ground because we have the kids running around, and even building a fence around it wouldn't be safe enough. However, vertical wind turbines are not very efficient compared to the horizontal ones because they don't find the wind, so they don't make use of all the wind there is. And they're quite costly as well compared to the other type, which is just bad since they're not as efficient and they're more expensive. So this is the horizontal one, which is more common, and you're probably all familiar with this one. Yeah, the wind catches and propeller-like blades, and that's it turns the shaft, which then generates electricity. And obviously that power can be used in the school, because you saw how much power we actually use. But yeah, that's not good. And it's vertical. Yeah, horizontal ones are able to produce more electricity from a given amount of wind because they're able to turn themselves and find the wind. So they do have to be pointed in the direction. They don't need to be pointed in the direction because they find it themselves. However, because they turn and automatically try to find the wind and make the best use of it, there's a lot of stress on the blades to catch the wind, and because of this they wear off very easily and very quickly, and they have to be maintained at a high cost. And they need a lot of space because they're very tall and very big, and you probably need more than one of them to produce enough power. Yeah, and they're obviously dangerous to birds because they're higher. Yeah. And there's this thing called Bernoulli's law, which is used to calculate the maximum power that can be extracted from the wind, regardless of the type of the wind turbine. So it applies to both. And according to this law, the maximum achievable extraction of wind power by a wind turbine is 59% of the total kinetic energy of the air flowing through the turbine, which means that this is the maximum efficiency you can get from a wind turbine, which is actually a lot higher than it is for solar panels. So that's quite interesting, quite good. Then we looked at solar panels as well, and as I mentioned before, there's two main types: the photovoltaic, PV for short, and we decided to choose that one over the hot tube solar panels because photovoltaic cells are good for small scale, like the school, because it's not big. They've got active components of solar panels and these semiconductors like silicon. And those of you who went on the trip ages ago, you might remember that. We were introduced to that as well. And yeah, they're basically using the electrons from light rays, which are then guided into a current, and that's how the electricity is generated there. We also looked at the water heating on the tubes, but we discarded that, and then Sarah will tell you why.
And so basically it's the conversion of sunlight into renewable energy for water heat using a solar thermal conductor. However, we didn't choose this one because it does not store energy, and basically we're not here during the summer, so that will not be efficient for us. So that's why we didn't choose this one.
Yeah, so we thought because we get the most done in the summer, to make the best use of the solar panels, we would want to somehow store the energy, and because we can't even store it for that long, but using the photovoltaic cells, you can sell it back to the national grid, and that's basically the same as using it up yourself, whereas you can't do that with the hot tube water heating ones. So that's why we chose the photovoltaic cells over these. And then we found some solar cells in the lab, and we decided to see how much voltage is produced depending on the light intensity that is shown upon the cell itself. And then we connected the cells. We connected 2 cells in series, and we connected the cells to a data logger, and then we tried to graph the voltage against time, and we found that again, it was like a hat shape basically, but and yeah, that showed us that after a while the intensity of the light is no longer a limiting factor, so the efficiency cannot be like increased infinitely. There's a limit to it, and we had to take that into account when we looked at the power that would be needed for the whole school. That's why obviously you can't just rely on solar panels alone to power the whole school. And there's actually a graph on the next slide